Hey guys, I had someone send me a homework question and it was similar to this one. It's from section 1.7 homework. And I think in this chapter, you guys are reviewing the chain rule. So we're discussing the chain rule. And what they're doing here is they are just expressing the chain rule a little bit different than what we're maybe used to seeing. So they're using the definition of the chain rule. They're actually showing a function as two composed functions, or in this case, what you're going to have to do is actually compose the function and then find the derivative of the composed functions. So let's get to it. So what we have here is that my math lab is asking that we find the derivative of f of g of 3, or find that value. So what that is asking me to do is to take this g function, substitute it into that f function, find the derivative, and then we're going to substitute 3 in there. So I'm going to really quickly write the steps down that I am going to do. I am going to compose the function, which means I am going to substitute g of x into f of x. So that is my first step. My second step would be to find the derivative of the composed functions. And then the third step would be to substitute 3 into the derivative. Now I'm writing really quickly, and I know I'm terrible at spelling, so I apologize if I spelled anything incorrectly there, or if I will in the future. So let's really quickly kind of go through these steps. So step one, I want to take that g function and I want to substitute it first of all into that f function. I want to take all of this because this is telling me that g of x is equal to u and u is equal to 5 plus 9x squared. I want to take that and I'm going to put that right there in the place of that u. So instead of having the cubed root of u, if I substitute g of x into there, I have the cubed root of 5 plus 9x. So that is my first step, super simple. I substituted. My second step is to find the derivative. Now, I'm going to write this a little bit differently. I'm going to just take that cube root and I'm going to write that as an exponent, as 5 plus 9x squared to the 1/3 power. And the reason I do that is because I want to use my power rule. My power rule tells me that I am using my chain rule with this, but the chain rule's kind of like, we call it our extended power rule. So I can bring that 1/3 out to the front. We're going to leave what I have on the inside there exactly the same. And remember your power rule, you bring that exponent out front, then you subtract 1 from the exponent. So that will now become 1/3 minus 1 gives me a -3. But now my chain rule says I have to go back. I'm going to change my color because what I need to do now is look on the inside and find the derivative of the inside. Well, the derivative of 5 gives me 0, but the derivative of 9x squared will give me 18x. So that is my derivative. But what I want to do is simplify. So let's make a note over here that we need to always simplify. So, I have my derivative, but it's not in simplest form. So what I'm going to do is I'm going to take that 18x and multiply times 1/3, which is going to give me 6x. And we do not like negative exponents. So what I'm going to do is bring that negative 2/3 power. I'm going to bring that to my denominator, and that's going to give me 5 plus 9x squared. to the negative 2/3, or not negative, but now it is actually a positive 2/3. And I'm gonna change this just because um, in algebra, I don't know, my math lab may take it both ways, but what I noticed here, I'm going to erase this so it's a little bit clearer at the top. They gave me this problem um, in radical form, meaning I have a square root. But what I did is I changed it to rational form, meaning I took that square root and I rewrote it as a fraction, right? A rational exponent. So what I want to do, I want to make sure that when I put this in my math lab, that I'm going to write it the way that it wants it. So whichever form it gave it to me in, because I'm looking at this problem and it's not specific, I'm just being safe. I'm going to change this rational exponent back to a radical. So this would actually be 6x divided by the cubed root of 5 plus 9x squared, all squared. Now, if we look at my step 3, my final step, I asked us, or I told you guys, that we would need to substitute 3 into that derivative. So I have my derivative, and now I want to substitute 3. So step 3 would involve plugging in 3 into this derivative. That would be 6 times 3 divided by the cube root of 5 plus 9 times 3 squared, and then whatever all of this is, remember the radical, is going to be squared. So this would end up being 18 divided by the cubed root of, so let's look at this. We can do this together. Let's change my color of my pen. We don't need a calculator for this. So I have 3 squared, which is 9. Let's remember order of operations. So 3 squared is 9. Then I have, that's going to give me 9 times 9, which is 81, right? 81. And the 81 plus 5 gives me 86. So this is actually going to be 86 squared. Now, typically I would try to simplify that 86, but what I noticed is if I were to try to simplify that radical, that 86 is just would factor down into 2 times 43, and there's really not anything else I can do there, so I can't simplify that radical. So I can't simplify it. So in my math lab, this is the answer. I plugged it in just to make sure, and that is the correct answer, and that's the form they wanted it in. And I know it looks kind of funny, but that is the derivative of f of g of x, right? And then I substituted 3 into that function, and that's what we got. So guys, remember, anytime you have questions with your homework, I am happy to help. Just shoot me those problems.